Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to some important theorems and their corollaries from calculus for everybody. Now today we have another very interesting result from calculus. So it says that continuity of a function at a point does not imply differentiability at that point. So if f is continuous at a point, then it is not necessarily differentiable at that point. This is also very unique and important result. We can see that if we have a continuous function at a point, then it is not necessary that it is differentiable. So we just need to find one example and we will be enough, we will be done with it. We just need to construct one single example, a function which is continuous at a point but not differentiable, then we will be done, to show that continuity does not imply differentiability. So before I start with that, I'll give you the alternative definition of derivative at a point. So derivative at point A is given by limit x goes to a of f of x minus f of a divided by x minus a. We will use this definition and show that we have a function which is continuous at a point but not differentiable. I'll be going for the favorite example that we have. I'll consider this function absolute of x. There is no issue in its continuity. You can at 0. Okay, so I'll check continuity at x equal to 0. You can see that function is satisfying the assumptions of continuity because f of 0 equal to 0, it is defined. Limit also exists at 0. It is 0, but we can say that f of x is continuous in fact at 0. F of x equal to absolute of x is continuous at x equal to 0. Now we will show that this is not differentiable at x equal to 0. Let's start. So I'll use this definition. So derivative of this function at 0 will be equal to limit x goes to 0 of f of x or absolute of x minus f of 0 is 0 divided by x minus a, which is x minus 0. This is equal to limit x goes to 0 of absolute of x over x. Now this limit does not exist. Why it does not exist? There can be many reasons, but one graphical reason can be given, and I can show you one graphical reason for this. Let me show the plot of, here is the plot of this function absolute of x divided by x. So you can see that from left it is approaching to -1 and from right it is approaching to +1. So you can see here that left and right limits are not equal. In this way you can say that the limit does not exist. So this limit does not exist because from left side this limit is -1 and from right side this limit is +1. Because this limit does not exist, as a result this derivative which is equal to this also does not exist, or we don't have derivative. We don't have derivative. So we have continuity but we don't have differentiability. So there are many functions which are continuous at certain points but they are not differentiable at those points. This should be kept in head.